Today's lesson, we still talk about proofs. We're adding on one more step to proofs. If you've seen, all the proofs that we've done so far have just been to say that triangle 1 is congruent to triangle 2. Pretty boring. That doesn't help us do a lot of things in this class, saying a triangle is congruent to another triangle. So we add on extra steps to the end to kind of help us get to where we want to go. So the main reason that we're going to do this, or the main reason that we can do this, is something called CPCTC. This is an acronym that's just going to make a long phrase nice and easy for us. CPCTC says that once we know two triangles are congruent, then every other corresponding part in there must also be congruent to each other, right? So we have been proving triangles are congruent with 3 pieces: SSS, SAS, ASA, AAS, right? One of those reasons, each having 3 parts. Well, there's 3 other parts in any triangle that could be congruent. So that's what CPCTC says. It says those other 3 parts that we haven't talked about yet, those are also congruent by this property. Okay? It is literally says corresponding parts of congruent triangles are congruent. Let's all say it together so that we get it into our brains. Repeat after me. It says corresponding parts. And you say corresponding parts. Oh my gosh, we're going to do this all day. Corresponding parts. You guys. Repeat after me. I'll pause the recording. Get ready for it. All right, so I need to recollect my thoughts. Triangle proofs in a nutshell. This is exactly what we were doing the day before, right? We need 3 pieces, some combination of 3 pieces of congruent sides or congruent angles. Then in a 4th step, we say that my triangles are going to be congruent. This is not going to be our prove reason anymore. So you know how it says prove? We can't just steal this from the prove anymore. We're going to have to write these ourselves and know that they go right after we have 3 pieces are congruent. And then we use SSS, SAS, ASA, AAS to then say that these triangles are congruent. Okay? Then, once we have said that the triangles are congruent, we use CPCTC, our new friend right here, to then say, well, anything in those triangles could be congruent. So let's say maybe this side is congruent to this side, right? As long as they are the corresponding parts, we can say that now. Sometimes there will be a secret 6th step. This is like extra. So we also have to watch out for that. But essentially, this is the form that these are going to take every single time. Can we look at this one first? Because it's already written out for us. So essentially what we're doing here, take a look at your givens. Take a look at what we have. I have these are an angle that are congruent to each other here and here. That's one angle. I have sides that are congruent. That's one side. I take 2 steps to figure out my next part. All right angles are congruent. That's here and here. So those are my 3 pieces, right? In step 5, I say that my triangles are congruent through ASA. And then my goal here is to say that EF and EG are congruent. Well, I wouldn't usually have a reason to be able to say those things because they're not reflexive, they're not vertical angles, they're not alternate interior. But now that I have CPCTC, I can say those 2 things are congruent because I've just proved that the triangles are congruent, then the corresponding parts are congruent. Does that make sense? That this is the pattern we're following here? Okay, so let's look at number 1. I'm going to take my proof statement. Look at that proof statement. It looks different now. I'm going to put it at the end. I don't know why necessarily. I'm not going to hedge my bets and say that it's going to be CPCTC because sometimes it's not. Then I'm going to go back to the beginning and I'm going to take care of those givens. Q and R are congruent. That's my first piece. This is R over here, by the way. Second piece, angle QPS and angle RSP. Then I'm looking for that third thing. What's the third thing? Greta. PS is congruent to SP. Okay, here's a crash course. Let me help you out with this real fast. If I take a look at these two triangles, I'm going to call this one triangle 1 and this one triangle 2. Cover up triangle 2 with your hand. If I call that one PS, I am going from having no tick marks over here to 2 tick marks over here. Okay? No tick marks to 2 tick marks. So then cover up triangle 1 with your hand. I'm going from having no tick marks over here to 2 tick marks over here. So that means I have to go PS in triangle 1 to SP in triangle 2. Does that make sense? How we label those things backwards like that. So PS is congruent to SP. Just because I flipped the order doesn't mean it's changed. It is still reflexive. It's congruent to itself. POC. And now we have my 3 parts. I have 2 angles and I have a side. So now I'm going to say that my triangles are congruent. I'm going to say triangle, and again, order matters here. Triangle, let's go with RSP is congruent to triangle QPS. Just like I just did with those reflexives, I'm lining up those sides based on how many tick marks each angle has. Why do I know that those 2 triangles are congruent? What's my reason? Caitlin? That one is AAS. And now look at my proof statement. I know those 2 triangles are congruent. I'm trying to prove that SQ, this line right here, and PR are congruent. Well, now I know that because corresponding parts of congruent triangles are congruent. CPCTC. That's going to become our favorite acronym. Any questions on that? Flip it over. Oh, goodness gracious. All right. Starting with, I'm going to take my proof statement. I'm going to put it at the end. Whoop. All the way down there. Okay. Angle P congruent to angle Q. Go back up to your first given. KL perpendicular to PQ. That doesn't tell me anything is congruent to anything else. So what does that tell me? What am I putting in for step 2? Caitlin. These 2 angles right here must be right angles. What's my reason for that? Go ahead. I still haven't said anything is congruent to anything else. So then what do I have to do in step 3? Anna. Bye. Perfect. Now I have finally said that something is congruent to something else, and I can move on to my next given. KL bisects angle PKQ. That doesn't tell me something is congruent. What does that tell me? Or what is my next step? Kaylin? Perfect. Here's PKQ. KL is this line. It says I divide those angles into 2 equal pieces. So angle 3 is congruent to angle 4. Our reason is Anna? Lovely. Okay. I've got 2 pieces. I'm out of givens. I need a third piece. What's the third piece? Caitlin. KL is congruent to KL. This time I don't have to swap anything around. If you look at the way that those 2 triangles are set up, K up at the top with 1 tick mark, L up at the bottom with the right angle, it's the same in both triangles. That's reflexive. What's step 7? Follow that pattern. I now have all my 3 pieces. What do I need in step 7? Allegra? I say triangle. Let's go with, I'll say KPL here. Is congruent to triangle what? Line it up. If I said KPL, the other side is, Aubrey? KQL. Why? What's the reason? Casper? Perfect. Side is sandwiched in between 2 angles. And then in step 8, it says, okay, now prove that P and Q are congruent. And we know that because of our friend. Anna? CPCTC. 3 C's, a P, and a T. Okay. Couple more. Again, step 4. Number 4. We take that proof statement, I'm putting it at the end. Whoop. Then I'm going to go through my givens. Let's go through them. RN and MD. Parallel. That doesn't tell me something is congruent, so I must know more. What does that tell me? If this and this are parallel. Interesting. You have to draw a transversal. Caitlin?
Angle 7 and angle 8 are congruent.
So we drew this transversal. I have to pay attention to what angles are actually being like sandwiched in between those lines. 7 and 8 are those 2 angles. So I would say 7 congruent to angle 8 by, what's our reason? Casper?
Parallel lines by alternating 3 angles are congruent.
Lovely. Look at how I didn't choose 4 and 3, by the way. 4 and 3 are not sandwiched in between those 2 sides. Okay. Sometimes it helps to work a little bit backwards here. So now that I have that those are congruent, I'm going to use my MN bisects RD. Bisects RD. Let's look at, this is given. What does that tell me? MN bisects RD. Ooh. What 2 pieces does that give me? Anybody? 2 pieces. Anna. RX is congruent to DX. Perfect. That's by what?
Definition of segment.
As opposed to definition of angle bisector, we do have to be careful there. There is a difference. And now, here's where it might be useful for us to start working backwards a little bit. I know that my goal is MD congruent to NR. Let me highlight that. Which means, you see how there's so many triangles in this diagram? I'm proving two specific triangles are congruent here. So I need to make sure that the two triangles I am proving congruent are this triangle here and this triangle here. So that means I'm looking for one more piece that's going to help me prove those two triangles are congruent, which would be step 5, Casper. Why? All right, step 6, name those two triangles. If I start with RXN for my first triangle, what's the other triangle? Anna? Perfect. Oh, I didn't highlight this. So then what's my reason? My two triangles are congruent because of, Aubrey? And then my two pieces, corresponding parts, are congruent because of, Casper? CPCTC. Good? Okay, I got to show you this one more weird one. Take your proof statement. Put it at the end. What do we notice about this proof statement right here? Anything different? Same old proof statement we've been seeing over and over again. What's different in this proof statement, Anna? It is not saying something is congruent to something else. Remember, CPCTC literally means corresponding parts of congruent triangles are congruent. So if your proof statement doesn't say something is congruent to something else, don't rush ahead and put CPCTC in that spot for the reason. Because it's not going to be AG bisects NR through CPCTC. We're going to have an extra step this time. Go back to the beginning. I'm starting with NA is parallel to RG. What does that tell me? Here's NA, here's RG. You can use one letter if you would like to. What does that tell me? Oh, maybe? Yes? No? NA is parallel to RG. It's one of my go-tos. What is it, though, Caitlin?
Angle N is congruent to angle R.
By what reason? Lovely. Okay, second given. NA congruent to RG. Third reason is what? I need my third thing. What's the third thing here? Aubrey? Why? Okay. Step 5 is what? I can start it off for you if you want me to. What if I say triangle ANX? What's the other side look like? Caitlin?
Triangle GRX.
Yep. And why? What's our reason? Casper? Angle side. Okay, now think about this. Now we've kind of hit our roadblock here. My goal is to say that AG bisects NR. What would I need to know if I wanted to say that AG bisects this side right here? Dahlia.
NX and X are congruent.
If I'm trying to say that AG bisects this line, then I would need to know that these two pieces, NX and RX, are congruent. How might we say that those two things are congruent, do you think? What would be our reason, Casper? Hold on, we're not there yet. How do we know step 6? How do we know that NX and RX are congruent? Huh? I heard. What is the reason that we know NX and RX are congruent? Anna. Yup, CPCTC. And now step 7, how do I know AG bisects NR? Definition of segment bisector. Oh, gosh.